This is AP Calculus AB. We're looking at 2003 question that's been released, question number 4. I know I've already got this stuff written down, but I'm just going to walk you through it, and hopefully it's going to make sense. Let f be a function defined on the closed interval from -3 to 4, and f of 0 equal to 3. So that's an ordered pair that we're likely going to use at some point, so I'd circle that right away. The graph of f prime, derivative, consists of a line segment and a semicircle as shown in the picture. Part A. On what interval or intervals, if any, is f increasing? Well, f is increasing whenever f prime is bigger than 0. We can see here f prime is bigger than 0 whenever the graph is above the x-axis. That happens from -3 inclusive until it gets to -2 non-inclusive. So f prime is bigger than 0 from -3 inclusive to -2. Therefore, the original function f is increasing from -3 to -2. -3 inclusive because it's above, -2 not inclusive because it's not above. B. Find the x-coordinate for each point of inflection of the graph of f on the open interval from -3 to 4. Justify your answer. Well, f prime is changing from decreasing to increasing at 0. So there's going to be an inflection point here at 0. F prime is changing from increasing to decreasing when the x value is 2. So there's going to be an inflection point here. Now when I say there's an inflection point, it means the original function. So long story short, if you're given the graph of f prime, every time f prime changes from increasing to decreasing or vice versa, the original function is going to have an inflection point. Part C. Find an equation of the line tangent to the graph of f at the point 0, 3. Well, easily 0, 3 means we're putting 0 in for x1 and 3 in for y1. This point slope form, this is the point of tangency. To find the slope of tangency, we look at the derivative f prime. What is the slope when the x value is 0? Well, let me rephrase that. What's the slope on function f when the x value is 0? The answer to that is the y value of f prime, because f prime is the slope. The ordered pair 0, -2 exists on f prime, so -2 is the slope, so you put -2 in here. Just to make sure this is clear, this ordered pair for f prime, when x is -3, the slope of the tangent line is 1. Here's another ordered pair, 0, -2. When x is 0, the slope's -2 of the original function. The x value on f is 4, the slope at that point is -2. You need to know all that, but just refreshing your memory on what all that means. Part D, find f of 3 and f of 4. Show your work that leads to your answer. So this f of 3, we need to couple this with another ordered pair that we do know, and that's here at 0, 3. So we know that when x is 0, y is 3. So we're going to integrate from -3 to 0. -3 comes from this. 0 comes from the fact that we have this other ordered pair. The fundamental theorem of calculus, part 1, says if you integrate f prime, you're going to get the f function. If I wanted to add a little bit of work to this, if this doesn't make sense to you, I could say this is equal to f of x evaluated from -3 to 0. If you didn't want to write that, that would be fine. So we know what f of 0 is. It's 3. We were told that here at the beginning. We don't know what f of -3 is. And to figure out what the area under the curve is from -3 to 0, let's look at our picture. From -3 to 0, I think that you would agree that this area is +1/2. Because this is a square that's 1 by 1, and it's half of that was make the triangle, so it's 1/2. Here, this is a square that's 2 by 2, so the area is 4. Half of that would be 2. This is below the x-axis, so this area is -2. So a half plus -2 is what I have for the area under the curve. It simplifies to -1.5. You subtract 3 from both sides, you get -4.5. Divide both sides by -1, and that tells us that the function, the original function, when the x value is -3, the y value is 4.5. Figure out what f of 4 is. Well, we could go from 0 to 4 here once again. 0 because we were given the ordered pair 0, 3, and 4 because that's what we're trying to figure out. Fundamental theorem of calculus says if you integrate from 0 to 4, it's going to be the antiderivative evaluated at 4 minus the antiderivative evaluated at 0. Now we don't know what f of 4 is. We know f of 0 is 3. We were given that all the way up here. What's the area under the curve from 0 to 4? So let's examine that. So here is the area under the curve from 0 to 4. What we have is this weird shape right here, which we don't know how to find the area of that weird shape. But we do know, sorry, I messed up there. But we do know that this is a rectangle. And if we get rid of the semicircle, that'll give us the area that we want. So the area of this shaded part here is going to be the area of the rectangle minus half the area of the circle, semicircle. This is 2 by 4, so the area of the rectangle is 8. The radius of this circle is 2. So 2 squared is 4, half of 4 is 2. Area of the semicircle is 2 pi. Area of the rectangle is 8. So the area of the shaded part is 8 minus 2 pi. So this is the area of the shaded part. It's negative because it's under the x-axis. So if I wanted to be a little bit more accurate here, let me change this to this area is negative. That's better. So we got the area. If you distribute the minus, and if you add 3 to both sides, f of 4 is negative 5 plus 2 pi. All right, that concludes this little explanation of 2003 AP question, problem number 4.